Hi there, welcome to my whirlwind tour of the electromagnetic spectrum. I'm just going to go through each of the parts of the spectrum quite quickly and introduce the different types. I'm quite sure you've already got some background knowledge here. So let's introduce some questions for you to think about. Okay. So here's my selection of questions. Think about if you know this already. Light, a type of radiation, is part of the electromagnetic spectrum. This is true. Visible light is part of the electromagnetic spectrum, and I'll be talking about it in more detail later. The electromagnetic spectrum is made up of different types of radiation. That is true, and I'm going to be talking about each one of them in the next few minutes. The different types of radiation behave or have different properties and behavior. True, that is what's going to make these things so interesting. They all do different things, which is quite fascinating. All electromagnetic waves can travel through space. Again, this is true. Electromagnetic waves do not need a medium to travel through. So that means they can travel through a vacuum, and all electromagnetic waves travel at the same speed in a vacuum. That's 3 times 10 to the 8 meters per second. That is true, and that is another well-known constant. So first of all, we introduce all of the electromagnetic spectrum. From increasing wavelengths, so I've got gamma rays as the shortest, then X-rays, ultraviolet light, infrared, microwaves, and radio waves. Now I have a sentence which helps me understand or try and remember the order, going from shortest to longest. I go by gate X usually lets in most radiation. So that's the tool that I use to try and remember what order they come in. So starting off with gamma. Now gamma is the highest frequency, the shortest wavelength, and has the most energy and is the most penetrating. Whilst radio waves, they have the lowest frequency, the longest wavelength, low energy, and are the least penetrating. It's actually radio waves I'm going to start talking about. Okay, so radio waves to start with, obviously used for creating radio. So communication, and also some fascinating areas of astronomy. You've got to remember, astronomy isn't all about just looking through telescopes. You can observe the world or the universe around us at all the different wavelengths which I'm going to be talking about. There's no real dangers associated with electromagnetic radiation because of these long wavelengths. It doesn't really interact with many things to cause any damage. Now, radio signals are really useful for transferring information and communicating because of the Earth's atmosphere. What we can do is we can bounce off longer wavelength radio waves off the Earth's atmosphere to allow us to communicate to people right on the other side. So that's kind of useful. Next up, we've got microwaves used for satellite communication, mobile phone networks, and also cooking. Cooking takes place is because it happens there's a certain frequency within the microwave section which happens to be the resonant frequency for water particles, and because there's so many water particles in the food which we eat, as they gain more and more energy, that causes the overall temperature of the food to increase. They're also used for radar. Microwaves can cause internal tissue heating, which is something which we want to try and avoid. Next up, we have infrared radiation. Now, infrared radiation is used for remote controls, also radiant heaters. Any heating device, in fact, anything with above absolute zero emits some form of infrared radiation depending on what temperature it's at. This is how grills work. Infrared radiation can also be passed through optical fiber and used for night vision, and night vision taps into some of those ideas about different temperature. It can cause skin burns if you're exposed to enough infrared radiation, so that's something to be wary of. So, back to the night vision. Now, all objects above absolute zero emit some infrared radiation, and that's dependent on the frequency, is dependent on the temperature which is at. If we look at the picture we have here, we can identify the hottest and the coolest parts of this deer. Light is hot, so that indicates that there's a lot of heat being given off through the antlers, whilst dark is cold. So those eyes don't have the opportunity to give off much heat. Visible light. Okay, so visible light, here I'm showing the rainbow, and that indicates or explains that all the different colours of the rainbow are part of are just different frequencies of the wider electromagnetic spectrum. Uses, well, clearly for sight. Okay. Dangers, we do have to be careful when we're looking directly into the sun, because that can damage some of the sensitive rods and cones inside our eyes. Then, ultraviolet radiation. Now, ultraviolet radiation is the radiation which we use in sunbeds and use in fluorescent lamps, and also for security markings as well. High doses can kill cells, so that can be a good thing, but lower doses can cause cells to become cancerous. That's something which we want to try and avoid. This is why you should always put suntan lotion on if you're going out in the sun, because those lower doses can be dangerous. As it happens, this is something which we're most aware of just because we're exposed to a lot. Ultraviolet isn't the most dangerous radiation. Gamma is more dangerous because it has more energy, but it happens to be something which we're exposed to a little less often, so this is something which we need to be constantly aware of. The interaction with living cells is something which we need to be really, really aware of. So infrared radiation, which we use, as I said earlier, for cooking toasters and things like that. Ultraviolet can pass through the skin into deeper tissues, and that's something which we want to try and avoid. So, the colour of the skin has an impact on the amount of radiation that passes through. Darker skin means more ultraviolet radiation is absorbed, and therefore less can reach into deeper soft tissues. So that means the darker skin means that top layer stops that deeper tissue getting affected, and that's where the cancerous growth can be caused later on. X-rays. Well, X-rays allow us to look inside luggage and inside the human body. Again, high doses can kill cells, but lower doses can be cancerous. It's something which we need to be aware of. Especially if you're in a hospital situation, gamma rays and X-rays are often around, so that you'll find that people often stand behind shields, and they'll have detectors which allow them to know how much exposure they've possibly had. Now, how X-rays work. X-rays can penetrate soft tissue, but not bone. X-rays are absorbed by some materials more than others, which means that if we recognise where some X-rays have gone through and some X-rays haven't, it allows us to use photographic film to create these X-rays of inside our body, and that's something which is really useful. Last but not least, I have gamma rays. Now, gamma rays can be used for killing bacteria in food, sterilising surgical equipment, and killing cancers, because there's a lot of energy there, so they can cause a lot of damage. At the same time, if you're exposed to gamma radiation, it does potentially increase the likelihood of causing cancer. Those are the electromagnetic spectrum, and that's for you to think about in a little bit more detail.